So we all do this right. We invest thousands into these massive 8K displays, and we obsess over the perfect surround sound receiver, and then we just grab some cheap checkout aisle cable to connect it all together.
Right, it's the classic bottleneck.
Exactly. So today we're doing a deep dive into the literal backbone of high-end setups. Specifically, we're looking at the Kramer CLS-AOCH-UF-33 ultra-high-speed HDMI Optic hybrid cable.
It is definitely a mouthful of a name, but honestly, if you care about signal integrity, this is the gear you pay attention to. We pulled the specs today from HDTVSUPPLY, and they've been curating AV tech globally for 25 years now.
25 years, yeah. And our mission today is really figuring out why standard copper cables basically just give up the ghost when you demand high speed over a really long distance.
Because most people just assume a cable is a cable, but this Kramer model is marketed as a solution for sending massive data, specifically 8K video, over distances that would make a normal HDMI cable completely useless.
And the secret sauce here is in the name, right? The hybrid part.
Yeah, exactly. This isn't just copper wire stuffed in a plastic tube. It is a combination of OM3 fiber optics and copper wire.
So it is effectively using light instead of electricity to move the picture.
Precisely. Light travels way more efficiently than electricity over long runs. That fiber construction means it can transmit 8K signals at 60 hertz.
Or 4K at a blistering 120 hertz.
Right, up to 100 meters. That is 328 feet with zero signal loss.
That is wild, because usually if you run a standard copper HDMI over, 20 feet, you start seeing starkles or the screen cuts out entirely?
Yeah, and to prevent that, the cable uses active electronics. It has an optical to electrical converter built right in, specifically a 4-channel 850 nanometer VCSEL array.
Right. I saw that on the spec sheet, and VCSEL array sounds like something out of a sci-fi novel. What is actually happening inside that connector?
It stands for vertical cavity surface emitting laser. So just imagine these tiny lasers blinking billions of times a second. They take the electrical signal from your Blu-ray player, turn it into pulses of light, shoot it down the fiber, and then convert it back to electricity at the TV end.
Because it is light, there is no resistance.
Right. No magnetic, exactly, just pure data.
Yeah.
And speaking of data, the bandwidth on this is rated at 48 gigabits per second.
Which is just a massive pipe, big enough to carry HTCP 2.2, dynamic HDR, and DSC, right, the display stream compression.
Yeah, DSC is huge here.
I was wondering, compression, though, doesn't that degrade the picture for the viewer?
Actually, not with DSC. Think of it like a really efficient zipper. It squeezes that massive 8K signal down so it fits through the pipe, but when it unzips on your screen, it is mathematically lossless. Your eye literally cannot tell the difference.
Okay, but with 48 gigs of video flying through, is there any room left for the audio, or does that get squeezed out?
Oh, there's plenty of room. It supports EARC for high-quality audio return, plus PCM 8-channel, Dolby Digital True HD, and DTS HD Master Audio. It handles the whole home theater package.
Okay, and despite all that tech inside, the cable itself looks surprisingly thin in the photos.
That is the beauty of fiber. It is only 4.5 millimeters thick, so it is lighter and way more flexible than those thick copper snakes we are all used to. But, well, there is one catch with these hybrid cables that trips a lot of people up. They are directional.
Directional? You mean I can't just plug either end in anywhere?
No, you cannot.
Yeah.
Because of those lasers we talked about, the VCSEL array, one end is explicitly marked source and the other is display. If you run this through your ceiling and plug it in backwards, you get absolutely zero picture.
Oh man, that would be a nightmare to fix, especially if you just sealed it up in the wall. Speaking of walls, though, the listing emphasizes LSHF for the jacket. I assume that is just a fancy way of saying durable plastic.
It's actually a really important safety designation. Low smoke and halogen-free. If you are doing a permanent install inside a ceiling or wall building codes often require this. Standard PVC cables actually release toxic gas if they catch fire, but this material doesn't.
So it is about keeping the building safe, not just the signal.
Exactly. And to keep the signal itself safe, they have these gold connectors.
Right, the 24K gold for corrosion, but the K-log thing stood out to me.
The K-log is brilliant. It is designed to provide about 15 pounds of restraining force.
So basically my cat can't knock the cable loose when playing behind the TV stand.
Yeah. Or if you are pulling your TV out on one of those articulating mounts, the cable won't just slip out of the port. It keeps the connection rock solid.
All right, we do have to talk about the price. HDTVSUPPLY lists this at around $256, which is, a lot for a cable.
It stings a bit, I know. But you really have to look at the context here. If you are running a cable 50 or 100 feet, usually through a wall, you do not want to do that job twice.
That is a very fair point. Tearing up drywall because a $50 cable failed is going to be way more expensive than $250.
Right. And consider the display you're feeding. If you drop 5 grand on an 8K TV, choking it with a cable that can't handle the bandwidth is just throwing money away. This Kramer cable is essentially future-proofing your setup.
It really does make you think about the weak links in our systems. So here's a thought to leave you with. What if that tiny fraction of a second of input lag you always blame on your wireless game controller is actually your brand new display waiting on a choked, outdated copper cable to deliver the next frame? Just like with anything, your setup is only as fast as the pipes carrying the data. Thanks for joining us on this deep dive.